Hello, welcome to our today's tutorial. We're going to focus our attention on sets. Now, by definition, a set is a collection of well-defined elements. Now, let us look at the common symbols that are used in sets. Now, for us to understand sets, we need to understand the common symbols that are used in sets. Now, the first part, or the first symbol rather, that we're going to focus on is a universal set. So for a universal set, in pictorial form, it looks like that. If you are given set A and B, all the members, including the universal set itself, that would be a universal set. It's all the members, including the sets themselves. So in this case, if we're given set A and B, the universal set is everything that is in that diagram. Now, the second symbol that we're going to focus on is the union of sets with the symbol U. Now, to understand union of set, it is all the elements belonging to a particular set or sets. For example, if we are given A union B, this is how it may look in pictorial form or in a Venn diagram. So it's all the members that belong to A and B. So all the members, union, that's what it will mean. So the second part is the intersection set with the symbol that looks like N. Now, in our understanding, intersection of a set are the common members that belong to two or more sets. For example, the common members of A and B, or rather A intersection B, would look like this in pictorial form. So this is where you're going to find the common members that belong to set A and set B. Now, the other symbol that we need to understand whilst we're focusing our attention on sets is the empty set. The empty set has a symbol that looks like a zero with a cross, or the curly brackets rather that have no element inside. That would be the empty set. Now, our main focus will be based on the complement of sets. This is where we find challenges, and we're going to make sure that these challenges are set down and handled. Right, so the complement of a set would look like an inverted comma or an apostrophe. Now, what do we understand by the term complement of a set? So complement of a set, ladies and gentlemen, are all members that do not belong to a particular set. The key word there is do not belong. So the common members, or rather all the members that do not belong to a particular set or sets, that is what we mean by complement of a set. I will repeat, all the common members that do not belong to particular sets. Now, let us focus much of our attention on complement of sets with examples. Now, when we say a complement, this is what we mean. We mean all the members, but not those members that belong to this set, which is set A, except those members that are in set A. Moving forward, when we say A intersection B complement, it means all the members except those that belong to the intersection of A and B. And this is how it will look like, except this region where the two sets are intersecting, but all the members. And then when we say A union B complement, we mean all the members that are in A and B together, those that do not belong to A union B. So A union B are these two, this one and this one, but all the members outside that region would belong to A union B complement. Moving forward, the fourth part, what if we say A intersection B complement? We mean those members that are in A together with B, but except those that belong to B. So this is how it may look. So that's just it. And then we move on to the next part. What if we are asked to find A complement intersection B? So we mean those members that are outside the A region, those that are outside the A region, but are intersecting with B. So this is how the set would look like. Now, moving on, the sixth part is where we're going to focus at A union B complement. Now, the union itself changes the face of the shaded region. It means the diagram is going to look like that. We have our A together with B, our A together with B, but union. So the B part is the one that is complemented. So except the region for B, but since A is included, so part of A is going to be shaded. That's the diagram will look like that. Now we move on. What if we are asked to find the region A complement union B? Just like we did in the previous, part 6 rather, this is how the diagram will look like, except those that belong to A. But since B is included, meaning part of B is going to be, the whole part of B is going to be included in outside region, but the A part is not going to be included there. We move on. Now, we need to understand the relationship between subtraction and complement of sets. We need to understand this because this will be very vital if we are trying to prove or verify sets. So, follow me through as we look at the relationship between subtraction and complement of sets. So, what we mean when we say a complement, it means all the elements except those that belong in set A. So, by subtraction, we simply mean all the elements, which is universal set, except those that are in A. So meaning removing all the elements that belong to A. So this is how it's going to be. What if we say B complement? If we say B complement, it means all the elements universal set, and then we remove those that belong to B. I hope this makes sense because you need to commit such information to memory. We move on to the next part. What if we say A intersection B complement? We mean the universal set, all the elements except those that belong to A intersection B. The same idea or the same principle, we're going to apply it here. What if we say A union B complement? It is again all the elements universal set except those that belong to A union B. So you see, ladies and gentlemen, why complement is important and there's need for us to understand it. Right, so moving forward, let us look at a few examples on how we can deal with questions to do with sets and their relationship with subtraction and complement. Now, for the first example, it says given that the universal set has those members 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And set A has members 3, 5, 7, and 9. Set B has members 4, 5, 6, 7, and 8. And C has members 1, 3, 6, 8, and 9. Now, the question here says, list each of the following sets. So we are asked to find the following sets. A intersection B. Now, for A intersection B, we are going to get our A set. So the members in A are those ones. So just lay them down, and then the members in C, we still lay them down. So we need to show our working, ladies and gentlemen. So this is what we're going to have. We are going to have our members in A and our members in B, in C rather. So these are the members in A and these are the members in C. And our key symbol is intersection, which is here. Right, so once we do that, it means we're showing our working. So now intersection, remember to say it means those common members that are found in both sets. Right, so which ones are the common members? So you just check. Do we have 3? Yes, we have 3 here, we have 3 there. Do we have 5? 5 is not there. 7 is not there. 9 is there and there. So the two members, there are only 2 members that are found in set A and C. And this is how we're going to write our answer. So we say therefore A intersection C is that one. It's as simple as that, ladies and gentlemen. Now we move on to the next part. What if we are asked to find A union B? Now from our list, we know which one this is set. This is our set A, and then this is our set B. So since the question is asking us to find A union B, we've listed the members in A. Actually, we've listed set A and we've also listed set B. And then we understand to say union simply means all the members that belong to 2 or more sets. So in this case, all the members without repeating, we just write 3, 4, 5, 6, 7, 8, and 9. And that will be all. Now, let us focus our attention on the third part, which says A intersection B complement. Remember, when we say A intersection B complement, we simply mean the universal set minus A intersection B, meaning all the members that belong, or all the members rather that are outside A intersection B. Now, how do you write that expression down? So we're going to list the universal set. So this is the universal set because we're saying it's all the members that are outside A intersection B. So the universal set is that one. Then this is a minus, so we're going to bring it here, and then we continue. And then in the bracket, since we have these in brackets, we're going to have to use the grid brackets there, and then we have our set A and our set B. So we're going to begin with those that are in the brackets. So we know to say what members are common here and here. So the common members are 5 here, 5 there, 7 there, and 7 there. So we have 5 and 7, just like that. Now, the minus part is something that you need to understand as well. Minus is simply subtraction, meaning we're removing 5 and 7 from the original set here. So if we remove 5 and 7, this will go and that will go. So which members have we remained with? We remained with 1, 2, 3, 4, 6, 8, 9, and 10. And that will be our answer. So we simply say therefore, A intersection B complement is going to give us the members 1, 2, 3, 4, 6, 8, 9, and 10. And this will be our answer. Quite easy, huh? So we'll move on to the next part of the question, which says A complement union B complement. Now what happens if we are given something like that? Well, it's quite simple. Looking at where we're coming from, Well, so we have our A complement simply means all the members that are outside A, so meaning it's universal set minus A. And then this is our union, this is my union. For B complement simply means all the members, universal set minus B, all the members that are outside B. Now, we'll still follow the same sort or the same pattern where we have our universal set laid down there, and then we have our minus sign, and then we have our A part. Now, if we are given something like that, it simply means the first part, this part here, this is just the first part of it all, which is A minus A, or so rather E minus A. And then the second part, rather we have the part that is joining the two, which is the union there, and the second part, this one, the universal set minus the B part, is simply this. I hope you're following. Right, so in this case, we know to say minus simply means we remove. So from the universal set, this one, we're removing 3, 5, 7, and 9. So 3 is gone, 5 is going, 7 is going, and 9. What numbers are we going to remain with? We'll remain with 1, 2, 4, 6, 8, and 10. So this is our union. And then from here, we're removing 4, 5, 6, 7, 8. So if we are removing 4, 5, 6, 7, 8, what members are we going to remain with? We'll remain with 1, 2, 3, 9, and 10. Now, since the key symbol that is connecting the two sets is union, simply means all the members, combine them but do not repeat. So therefore, we'll conclude by saying, therefore, A complement union B complement, the members that are well found are 1, 2, 3, 4, 6, 8, 9, and 10. And that will be all. Right. So this has brought us to the last part of our tutorial. So look out for the next part as we break down a few questions and do a lot of practice on sets. Thank you for watching.